So boom, we're recording now. So I just got done talking a little bit about APIs and some problems that typically happen with APIs. Essentially the issue, an API, application programming interface that connects two applications together, it's going to specify what sort of interactions are possible. And so you may see things that you think, wow, the syntax is correct on this, this ought to work. But if that feature is not specified in the API, then it's just not going to be there. The code's not going to have any place to go when you try to do things your way and not the API's way. And one of the examples of this is with automatic file loading. So take a moment, read this, pause the video, whatever. Another thing that came up was images. So we talked about canvases the other day. So let's talk about canvases. With a canvas tag, we can draw images and we can draw custom graphics like polygons and lines. Okay, so we've done all that, that's fine. But the interesting thing is the way the API is structured, once you draw an image, right, that is, you lift an image from a file and display it in your canvas. The canvas can no longer be used for custom graphics. Okay, and if you don't know that that's a thing, you can spend quite a bit of time trying to figure out what the problem is. Even if you go around and look on a bunch of resource sites, you know, the experienced graphics people that write these pages, they're going to kind of assume that you know that, and it's a difficult piece of information to acquire. So what you can do instead, suppose you want to have an image as a background, okay, and then draw custom graphics over it. Well, one thing you can do, you can convert your image to a bitmap, right? So a .bmp, then go to some online source, go to some online resource and download that data, right? Basically, and convert the .bmp file to just plain raw image data, right? Which is going to be a sequence of 24-bit values, right? The RGB. Do that. Then, with that binary file, load it in as an array buffer, basically a kind of array, an array buffer to be specific. And then copy the values into the canvas basically as individual pixels. So these are some headaches you have to jump through to get around the limitations of the Canvas API. But here's what I have. So I'm going to show this here. Where's my fall 2020? I loaded all this stuff up. So do I have my, oh, I'm going to need to copy that from my desktop. Okay. So this one, this is the image. I could just do it here, I guess. So this is the bitmap. Okay, so what we have here, there's a canvas where things are going to get drawn. There's an input type file. It's going to let me select a file and I'll pick which one I want to include. And then I have a couple of buttons that do some stuff. So we'll see. So when I open the file, when I do this input event, I open the file, it creates this event function. And the short version of that is after the thing finishes loading, it's going to assign all the data to an array buffer. I'm going to have a little note here in a paragraph tag. This is just for diagnostics to show that it works. I have this little note here in the paragraph tag that shows the length of the array. And then I'm going to call this display method. Well, display method is going to take whatever file I've loaded, whatever binary file I've loaded, and display it. So what we do here, we have our var that applies to the context, C, or to the canvas. C is just the canvas. So var C is how I reference the canvas. CTX is the context for the canvas that I'm going to use to draw. I'm going to pull a batch of data from the canvas, and this data var, that's going to be an array. That's going to be a big byte array of that 0 by 512 pixel square. And then every get image data, right, this object that gets returned, it has its own data attribute. So I can read the data from it. Now the other stuff that I'm going to do, all that data that I read from the binary file, I sent that along as an argument when I called display, right? So if you look here, you see display, I'm sending along array buffer. So that array buffer is received in the display method as this AB. These 3 lines basically take that buffer data and convert it to a sequence of bits, or a single sequence of bytes. So at the end, this ABX is in the same format as this PIX. So I can zip through the 2 arrays. So I start here with a loop. I start both I and j at 0. I references the PIX, right? This what's actually there on the canvas already. And j references the data that I loaded in from the binary file. So I go through as long as I haven't reached the end of ABX, I haven't reached the end of my array buffer. At the end, I jump ahead by 4 on each because they're both in the same format. So the first 3 bytes, I just copy over. So pix I equals ABXJ, pix I plus 1 equals ABXJ plus 1, and so on. And then this is for opaqueness. When I say 255, it's going to be opaque, which means that this ABX value is simply going to overwrite the pix value. Then once I've done all that, I've gone through the entire ABX array, and I can post the image up there. Okay, so put image data, starting with data. Data is going to be this pix stuff. That's the data that I'm going to push, and I'm going to start it at coordinates 0, 0. Now this is something you don't see in your code. I just drew a black circle on there for diagnostics. So I'm going to get rid of that. Don't really need it. Save the file. Now bitmap matches yours. So all that's happened, right? As when I click, I don't even need this load anymore. I can get rid of that. Maybe I'll update the I'll update the file I have on Blackboard later. Okay, so there'll be a button here. There'll be an input type, and if I want to select a file, I can do that. Also, I have this adjust button. So there's a button at the top of the screen. It calls an adjust method, an adjust function when I click it. So what adjust does, first it's going to say, okay, adjusting. That's just for diagnostics. I'm going to do the same thing. I have a C to reference the canvas. I have a context that I can draw on that canvas. I'm going to pull a batch of data from the canvas. So again, the square from 0, 0 to 512, 512. And I'm going to set up an object that holds all that data as a byte array. So I scan through the entire byte array. Whoop, that should be green and blue. Okay. Each of these values, I'm going to increase by 16. So as I keep on clicking adjust, the image is going to fade out. So it starts out as an image of Chicago, but as I press adjust, it's going to fade out. So remember, as each of these values get to 255, the luminance gets brighter and brighter. Eventually, when they're all at maxed out luminance, they're going to be essentially invisible. And then that's just going to take all that data and push it back to the canvas. So we can run this. Open up my files here. We got bitmap, boom. Okay, so here I have a browser, it's waiting, there's adjust. When I click browse, I can select my file. I'll select chai bin, boom, there it is. Okay, I can copy that in. And unlike a normal image, I've gotten a workaround with the API, so I can click adjust. Wow, it's getting bright. I can't see. There it is. Okay. So this is a simple coding example for how you can create your own custom graphics even over existing images. It is a bit of a headache, but it can be done. Okay. Questions on this? Any brief questions? I mean, this is just the intro to it. The big thing today is we're going to look at Slug Fall, and we'll see how that goes. We're going to clean up the code for that, and then, you know, and talk through it while we do it. The code is a little sloppy, but I figure in the process of cleaning it up, I can also explain what's going on in it. Okay. Questions? All right. So again, one of the things with this, when you're editing this kind of code, you want to do it in small chunks. You want to save an original copy of whatever you're working on when you're happy with it. Especially with Notepad, it doesn't have the full features of, you know, undoing stuff easily. So you don't want to lose a whole bunch of work and have to go back and scramble to try to fix it. So always keep a backup copy, whatever you're working on. All right. So we're gonna go ahead and start on looking at Slug Fall then. And then what I come up with the final on that, I'll also post that to Blackboard. Okay, so this is Slug Fall. For those of you who weren't here the other day, it's, you know, like I said, basically a game prototype. If I start it, level 1, here's my guy down at the bottom. I got slugs falling. I try to bump them away. It's not very sophisticated. The slugs are just polygons following different paths, but they're doing their things, and I try to smack them away. If one reaches the end of the screen, okay, we'll let that happen. La, 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 I'm not doing anything. Go for it, slugs, take over. Then the game ends, and there's a little animation for that. Boom. Okay, and then we want to start again once the screen goes back to normal. We can. Okay. Da-da-da. Okay, so you get the idea. All right, I'm going to destroy all the slugs. We're done. So we got a few things going on. We got this graphics down at the bottom. We got the slugs themselves. We got the background. We'll look at some of these features. And then if you ever want to design stuff like this for yourself or simple things to put up on websites, you'll know how to do it. Okay. So let's take a look at the code. I'm gonna get rid of that so I don't pull up the same screen by mistake. Okay, so this is the Slug Fall code, and we are gonna arrange it a little bit better over time. So the first thing, I like to put all my HTML stuff up at the top, and that way, there it is. Okay, so the first thing, when we load the page, right, we have this onload attribute for body. It calls a pull background method. That's where we're going to start. That's the very first thing that happens on our page. Other thing we have our canvas, and in the canvas, there's a few things. Number one, there's an on mouse move attribute, there's an on mouse out, and there's an on mouse over. So those allow 3 different actions. So the on mouse move, that's going to create an action when I move the mouse around within the area. Okay, on mouse move is for that. On mouse out is going to be the action that happens when I exit the canvas. And on mouse over is going to be the action when I move the mouse back in. So we have 3 different kinds of mouse actions: leaving, entering, and moving over it. This P paragraph tag, that's just for things like displaying the score or other messages. I've been using it as diagnostics as well. So just a paragraph tag to display a little bit of text. Okay, so we have some things here. This is a little bit complicated if we look through it all. But it's not too bad. It's about the same as that other game they have up on W3 Schools. But we'll look at this stuff here. So first one, I have C that references the canvas, and CTX, that it's the canvas's context attribute. Okay, these other things, we'll get into them when we need them. So there's a few other variables. Basically, I have some timers. I have a level that I track, so eventually there could be extra levels in the game. I have the coordinates of the user's object, things like that. And this is one of the things when I say, yeah, people get into habits of writing variables that may not be terribly descriptive for other users. Yeah, I'm guilty here. Okay, this happened. All right. So let's trace out the program first. The first thing that happens is pull background. So we're going to put all these functions in order, and put clear canvas up above. Clear canvas, go up above. It's a nice thing to put your functions in order so it's easy to find what you're looking for. Also, if I were more serious about this, I would have gotten something like Eclipse to actually do the JavaScript in. But Notepad is in some ways better, but not really. Okay, so here's the first one, pull background. So the first thing I do in pull background, okay, so I'm going to say get data array from the canvas. Okay, so that's what this image data is. We've seen this like before in the bitmap file. Okay, this var pix, the data array can be accessed as a byte array through its data attribute. So that's what I'm doing here. Var pix equals image data dot data. Okay, and then I have a loop. So again, and that byte array has a length attribute indicating length in bytes. Okay, so when I do this loop here, I start from I equals 0, and as long as I is less than pix.length, I'm going to go ahead and clean that up. I don't really need the separate n there. As long as I is less than pix.length, I keep going. At the end of it, at the end of the loop, so edit pixels in batches of 4 bytes. So there's a red, there's a green, there's a blue. This is the transparency. I leave it 255 to be opaque. Okay. And thus I overwrite all the data. Then once I've edited the byte array, after editing the byte array, use context, put image data to rewrite the canvas. Straight E up there. Okay, so that's what I'm doing here on pull background. So the very first thing I'm doing is just making the canvas black. Okay, so I'll write even that up above the function. Makes the canvas black on page load. Okay, so simple method there. Let's see what else I can put in there. Oh, draw slugs. We're going to get that and destroy. I'm going to move a couple things up so we have them where we need them. Draw slugs. Okay, we'll move more stuff in a minute. Okay, next thing. So what am I waiting for? So that's the first thing that happens and nothing else happens. So then the only other things that can start things, we got a couple of buttons, right? So down at the bottom here, I got some buttons. On-click start game, on-click destroy. So I'm going to bring them up to the top, up above the script. There are my buttons. Okay, so what do? Well, I have this one for start game, and this one for destroy. Destroy only matters if you have a game in progress. But so let's go we'll look at start game, see how that starts. Start game's down here at the bottom. So, as you might guess, this function starts the game. Haha. So first of all, right, update score to show 0 at game start. Right? Then what else? If there's no timer, okay, and what's D is -1, D is a value I just use to see if the game is in progress. Okay, so we'll see in a moment that D will eventually change when I'm doing some stuff. But D is if there's no timer, and we'll see in destroy here, I can show you that. And B set interval. Yeah, we'll just leave it there for now. If the game hasn't started yet, if there's no slug timer, then begin new game. So first thing, we're going to clear the canvas, and that is set canvas color to sky blue, more or less. We have a set of coordinates for a set of RGB for that. RGB values. Okay. We're going to start a timer. Start a repeating timer that calls the Slug Fall method, the Slug Fall function, at 20 millisecond intervals. Okay. And then the slug timer is set to true. So that's just a Boolean to indicate game is in progress. As long as the slug timer is running, the game is going on. Okay. So we got that. We got start game. Let's see, random color. All right. Slug Fall is the big method. Okay, this is one that's kind of long here. So we're going to break it up. So the first thing that happens, right, very first thing, we're going to call Slug Fall. That's all that's going to happen. So what happens in Slug Fall? Well, Slug Fall is the core repeating function of the game. It does a few things. Number one, okay, if necessary, displays the current game level. Okay, that's what we see here in the first part. If not falling, that means if, slugs are not falling, it's going to print out this. It's going to print out slug fall and whatever level we're on. Okay. Then, next thing, clears the old paddle. Then clears the old paddle image. How does it do that? Well, it basically overwrites it in white in a little bit bigger circle around it. We'll talk about that in a moment. Next thing it does, fades canvas. So it circles all through the canvas. So converges canvas pixels to sky blue by one shade of RGB. So each of these, right, the 173, 216, 230, those are our three RGB numbers. If that particular color is below it, I add one. If the color is above it, I subtract one. Okay, so all those, it converges to blue. That's how we do that effect. Okay, next thing, check for new slugs. Okay, so sometimes we generate new slugs. That's where they come from. So randomly generate new slugs. Then we draw them. Oh, drawing is somewhat difficult. We'll have a little bit more to say about that. Okay, so where's my, lost the header there, there we go. Okay, number 4, draw all active slugs. Then we drop them. Okay, so if any of them have reached the top, I'll say dispose of any slugs that reach the top. So normally slugs fall, but when you smack them back, they go floating upward. And if they go all the way up to the top, then we want to pop them out of our array so they don't keep consuming memory resources. Then we draw the new paddle, okay? And check bump and check end. So pretty simple there. 6, draw the new paddle location, and then check for object collisions. Did you hit a slug? And then last, check for game end. Okay, so there's a few things that are happening here. It's not all happening in the function, but most of it is. Okay, so the first thing here, if not falling, okay, so falling is a variable this is used is game in progress, okay? When we start, right, initially the slugs aren't falling, right? So I'll say as the first round of slugs started falling. So initially when we start off the game, no, the first slugs haven't fallen yet. So initially, this will be false. And so I'm going to print out this slug fall level 1 in the middle of the screen. Okay, so this text align center is how I do that. And the 240 is approximately the, just a little bit above the center of the screen. Okay, so display level message if slugs haven't started falling yet. Okay, at game start or level start. This one, clear old paddle. So okay, so this code here for the RGB FFFFFF, that's white. So what I'm going to say, as long as the thing is in bounds, if it's still in the canvas area and moving. Okay, so when I do this in bounds, that's going to be true as long as my cursor, basically, as long as the cursor is over the canvas. And as long as it's still moving. If I stop moving, then it sits there. You don't want to have it perpetually refresh for no reason. So if old X doesn't equal the new X or old Y doesn't equal the new Y, as long as it's moved in some direction, yeah, I'm going to clear out the old one. So this is just draws a circle, draws a solid circle. Okay, it's a little bit larger, than the cursor to ensure coverage. Okay, so I want to draw it all in white. So when I'm running this thing, right, you'll notice, let me see, where do I, there's my image. When I'm running this thing, if I stop, it all catches up. Okay. Boom. Don't really need to do that. But that's what I'm doing there. Okay, that's how I achieve that effect. Let me see. It gets a little hard to find all my apps. Okay. So that's it. That's clearing the old paddle. Fading canvas to light blue. Talked about that. Basically, for each RGB value in pix, move it one closer to 173.216.230 RGB code. And that's just going to make it, like I said, gradually fade to light blue. So every 20 milliseconds, the pixels are going to converge. That's how I achieve that other effect. Right? When the slugs leave a trail, even I leave my own trail behind me, it all fades out. You'll see it smoothly fades out behind it. That's how I just converge the colors to that same background color. Okay. Checking for a new slug. So this, every, 720 milliseconds on average, a new slug is generated. This time is arbitrary, but seems to work well enough. Different successive levels might use faster times for difficulty. Okay, but for right now, I'm just playing around with it. Make a slug like every 3/4 of a second or so. It works out all right. If I wanted to make it much faster, right, I could do it like, say, I could make it twice as fast. And I have a lot more slugs. It's going to get real crazy real fast. Ah, slugs. Oh no, oh shit, look at it's all, oh man, this is bad. Slugs are going to get me. There's no way I'm keeping up with this. I knock a few of them, but there's too many. I'm getting, that's life. That's life in the Slug Fall. Okay. Yeah, so that's a little bit too many, at least for me. Maybe you guys are twitchier. The other thing here, the math.floor function. Math.floor gives the integer after discarding any decimal portion. Okay, so the random, math.random, returns a floating point number between 0 and 1. Okay, so if I want to do random times 18, that's going to give me a random number between 0 and 17. It's going to be one less. So math.floor, right, that's what it's going to give me. It's going to just take away all that decimal stuff. Okay, so if I'm checking if it equals exactly 0, I need to have an integer for that. Okay, and if that's true, call my new slug method. Well, we'll check out that in a minute. All right, so this, the draw slugs, this is pretty involved as these things go. So what I have, right, the core of it is a loop. So first, capture data from canvas, right? That's our CTX, put image data. Where does that go? That belongs up there. Yeah, I've done some weird boundaries here. I'm just going to pull this. Okay, that's good. So capture image from canvas there. Okay, now drawing the slugs, need the loop for that, right? So going to draw each slug in the array slugs. Okay, so that's the name of my array for all the slugs that are active. It's called slugs. So starting at 0, and for every slug in the array, I'm going to do this drawing routine. So the first thing I check if it's falling. If it's falling, if the slug is falling, increment its y coordinate. Okay, that way move is lower down the screen. So it moves down the screen. Otherwise, not falling, so it moves up by decrementing y. Okay, remember, going up, smaller y values are towards the top of the canvas. Then we have some interesting stuff here. So these slug types, there's a lot of math here. Okay, but all I'm doing, if you want to dig around in it, you can. But what I'm going to do is basically figure out the difference between where the slug is, where it wants to go, move it along a line. Okay, so all these motion codes, basically, well, I'll just say they're plotting the appropriate x coordinate for the current y coordinate. In some cases, moving along a line. In others, along a curve. So, first one, if the slugs is not type 1, I have 4 types of slugs, 4 types of slug paths referenced by slug.type. Okay, so the type 1 follows basically a sine wave. Okay, but if it's not that, it's just going to follow a straight line. Okay, if not, type 1 moves in straight line. So the new x coordinate will just be the next spot along the line. So SX is the source, the starting x, coordinate. SY is the starting y coordinate. DX is the destination x coordinate. And dy is the destination y coordinate. Okay? And all I'm doing here find the x along that line from SX, SY to DX, DY corresponding to y. So wherever I am along that line, right, I know my y coordinate, I can plot out the x so it moves smoothly. Otherwise, if the slug is not, or actually is a type 1, it moves along a sine wave. Okay, and without getting into the math of this, this is what's happening, right? So it's gonna move along a sine wave. You can see there's some pi there, there's some radians. Yeah, but it's the same thing, right? But like the other slugs, the y coordinate is known. We need to find the corresponding x coordinate along the sine wave. Okay, so I mean, if you want to be fussy about it, it's a cosine wave, but because it's vertical, but whatever, you get the idea. Now, that's fine. There's a few other things. So these parts here, these are the random motions. Okay, so mostly slugs move along straight lines along a sine wave, but the random motions make them a little bit bigger, a little bit tougher to hit. So this one, random motions or random / changing motions, random or changing motions. So this one, if the slug reaches its destination y, right, it might change direction when it reaches a destination y. So if it reaches that, if the slug is type 1, okay, then the dy is going to change. Slug dy is going to be the new one, and I update that. So if type 1, update the destination y to be same distance further down from current y. Okay, so you initially started with a source y and a destination, starting y and a destination y. Once you reach that destination, then you make the new gap the same. So your current y becomes the starting y, and you add on the same amount as the difference so that the next step to the destination y is the same. That ensures, that keeps the sine wave same amplitude, right? Not amplitude, same frequency, vertical distance. So it looks the same as it goes down. If it's type 2 or type 3, if type 2, okay, then what do we do? Well, the source is going to be the current x, the start is going to be the current y, and I'm just going to randomly pick a new dx and dy, okay? Randomly pick a new destination x and y, okay? X will be horizontal, y will be a certain size down. So with dx, it's going to be random gap between, 10 and 500. So the canvas is 512 pixels. So it's going to be basically randomly distributed around that. The slugs, on the other hand, right, the y coordinate, that's going to be anywhere from 10 to 210 pixels down. So the gap could be very short if this y distance is small, or it could be, a fairly long one and a gradual turn. So it could go any, there's some variety of directions there. Same thing here. If type 3, we're going to randomly pick a new destination x and y. But y jump is smaller. Okay, so we can see here, this one, the jump could be up to 200 pixels. This one is only going to be about 100. So this type 3 one, it's going to change a lot faster. That's the triangle when you see, and you'll notice the triangle tends to zig more sharply. Okay, then drop slugs, right? We call the draw slug, actually draw the slugs. Actually draw the slug in its current location. So that's it. We call that method to do that. We'll look at that in a moment. So drop slugs, any slugs that are off the top of the canvas get removed from the slugs array. Okay, so that keeps, we don't use any extra memory for that. We'll say keeps program running reasonably fast over time, because we don't have this big array full of operations that we have to, it's going to slow down our stuff when the slugs are out of the game. Okay, draw a new paddle as a black circle. Okay, so here RGB is black. Okay, and also update the coordinates. To show that the new X and Y, are now current. Okay, so this is just going to draw a black circle, black unfilled circle. Okay, and then last, check bump. Check for object collisions. And then last, check for game end. Okay, so that's our whole slug fall cycle there. And it's a bit involved, but if you don't worry about the math, it's not too bad. So next thing, let's look at some of these things. Let's look at the new slug. Let's look at the new slug method. Where's our new slug? Here it is. Here's new slug. Okay, so new slug. What we do here, first we figure out the start. Okay, our starting coordinates, that's going to be our starting X. It's got to start somewhere in our map. Okay, default starting X coordinate. Then S is the new slug object with all these various attributes. So it has an X attribute, a Y attribute, has falling, which is by default set to true. The slug is going down. It has a color that we get from a random color method, has a starting X and Y coordinates. So the starting X is going to be the initial X. The destination X is going to be also a random spot within random X coordinate within the map. Our starting Y, it's going to be at the 0 coordinates, and our destination Y by default is going to be the bottom of the screen. So if it's just going straight down in a line, it wants to reach the bottom of the screen. And initially the type is -1, which is not a valid type. Okay, so then we assign a type, assign valid type 0 to 3. Okay, so math.floor, math.random times 4, math random times 4 returns an integer, turns a number between 0 and just less than 4. So the floor on that will return a random number between 0 and 3 and be an integer. So if type is 0, we just leave all this stuff as is, except for type will change. That's the default 0 kind. It just goes in a straight line to the bottom of the screen. And that's that. If type is 1, then we're going to do something different, right? We're going to have the starting X be a little bit closer to the center of the screen. So we change the initial X coordinate there because of the sign waviness of it. Move X coordinate closer to canvas center. The destination X is going to be straight vertical because it's following a sine wave. Then the destination Y is going to be some random gap down below. If S is 2, okay, so I'm going to mention this. This is a circle. Well, you don't know that yet. So this is follows sine wave down. Okay, the second one. Okay, this one, again, type has a slower zag pattern, and this has a quicker zag pattern. Okay, and then that's why the dy is dy minus sy is fairly large. Okay, and this one, the dy minus sy is fairly small. Okay, and then just draw the slug. So we'll call the draw method. Draw method, and then tack on new slug to the array. So let's take a minute. We'll look at the draw slug method now. It's pretty, where's draw slug? I think we pulled that up here already. There it is. Okay, so just draw slugs as different polygons or shapes by type. So type 1 is a circle, type 2 is a rectangle, type 3 is a triangle, and type 0 is also a circle. Okay, so not much to say about that. Tighten that up a bit. Okay, so that was our new slug method. Now, one thing we haven't covered, random color. How do we pull a random color? Well, here's our random color method. So what we want to do, return a random color RGB string, also not too close to sky blue. Okay, so what we do here, we have our variables red, green, and blue. As long as red, right, so we get a random number for the red component between 0 and 224. As long as it's not too close to the 173, so math.abs is less than 32, right? As long as it's outside of 32 away, we're good. If it's close to 173, we're going to try again. That's the do part. So we're going to keep on generating new red ones until we find one that's sufficiently far from 173. Then we convert it to a string. So this, I'm going to put in this, get random value for red that's less than 224 and not too close to the 173 of RGB sky blue. Okay, so that's what we're doing there. This part, convert red value to a hex string. Okay, so if red is less than 16, we need to append a 0 to the front of it. Okay, so we'll say precede hex string by 0 if it's small. Hex strings number between 0 and 15, hexadecimal, so base 16. Otherwise, okay, if red is single digit, then we precede it by 0. Otherwise, use as is. It's 2 digits, it's fine. Okay, and similarly for green and blue. Okay, afterward, precede hex string with number for color and attach RGB in order. Okay, so this is the hex string for red, the hex string for green, the hex string for blue. Precede that sequence with a pound sign, and that's our color string that we return. Okay, so that's random color. Now, almost the end of it. So let's go back to our slugs. Okay, we drop slugs, we draw the slugs. We've done draw slugs, we've done draw slugs. Last things, we're almost done. Okay, we just got to do the check for collisions and check for the game end. So check bump, that's this. So we'll mark that comment. Check for collisions. So each of these loop through to check all slug coordinate pairs for collisions. Now in this one, I just use a simple one. I don't use anything fancy. I just say, if the radius, the center of the object is 10 apart, then there's a collision. Okay. So this D here, D is the squared x difference, x delta, plus the squared y delta. Okay, so difference between two circles, basically. But that's what the difference is. If D is less than or equal to 100, the objects are sufficiently close that a collision happens, right? Basically, the center of one object bumps the outer edge of another. That's what the collision is. So when that happens, we're going to flip the slug around, right? So the slug is if the slug is falling, your score goes +1. Okay, we add 1 to the score, and we increase that. Slug has a new upward trajectory by assigning it a new start and destination coordinate set. Okay, so the SX, that's going to be some random one. The DX is going to be its current X, so it's going to be at its destination, but moving upward. The new SY is going to be -10, so it's going to move upwards towards the top of the screen. The DY is going to be the slug's current destination. So it's starting from the destination, moving back to the start. And if it's a type 1 slug, it no longer, follows the sine wave. Just a straight line. So there's that. Okay, and then falling is false. The falling attribute is set to false, so it can't get rebumped. Okay, so that's the collision. Basically, when you bump into one, it checks to see, when you get close to one, you check to see if they're touching. If they are, then it gives the slug a new trajectory. All right, last couple of things. Draw slow. So what was the other one? End game, right? So what was the check end? Must be here at the top. We got Doom, we got that, we got new slug. There we go, check end. Okay, so if any of the slugs, if any slugs reach the screen bottom, reach the canvas bottom, the game ends. Okay, so first of all, change color to bright red, right? We overwrite over the whole canvas. Boom. So we see that flash of red when the world ends. And then we clear the interval, no more timer, and we call destroy. So old slug timer stops because game is over. And then we go to the destroy method. Okay, so what happens in destroy? Okay, so this, we clear the slug array. Reset timers, right? Slug timer is false, it's no longer active. We have a clear interval, right? So that one's gone. And then if B, right? So we send along true because the game got destroyed. Then we're going to set an interval for doom. Okay, well, what's doom? Doom is just we're going to restore the screen. To allow replay. Okay, so again, there's a cycle every 25 milliseconds. These things change a little bit. This is what this D is used for. D attribute used to regulate the red background color after game end. Okay, so as we loop through this, right, each time, right, so D is initially -1, it brings it to 0, and we'll say if, you know, this one, if D is less than 173, then it equals D. So over time, it's going to keep on creeping up. Every time, it's going to be one more. Yeah. All right, so we're going to, yeah, we're going to restore the screen after that is what that'll do. Okay, and that's pretty much it. Only last thing, these mouse events. So anytime something, the mouse enters the screen, so we have this M for event, right? So on mouse move, M event. All that happens there is it borrows the coordinates. So we'll say here, reads mouse coordinates, assigns them to new X, new Y, okay? And then checks for bumps, right? We don't really need to check for bumps there, but we do. Yeah, but we check. Okay, anytime it's registered a mouse move, we also see if a bump has happened. So if we move through a slug, we're still going to get it. Okay, so that's it. I'm going to clean this up a tiny bit more before I post it all. I'm just going to put the functions in order, in alphabetical order. But this is pretty much what I wanted to cover today. And I hope people are still there, still following along. If not, you can take a little time. It's going to be recorded. later today, I'll get that next assignment put up. It'll be something, like I said, some kind of tic-tac-toe Connect 4 type game you get to put together. And I guess that'll be it. Any questions on this stuff? I'm going to stop the recording.